Alright, so in the last video we left off talking about other than 90-degree bends. But I keep talking about these charts, so I'm going to show you these charts. We have the bend allowance chart. For this, you have metal thickness. Get my highlighter out here. We have metal thickness and bend radius. So it depends what radius we have going across the top here, and what our thickness is going down this way, and where we're going to be on this chart. But where we meet up, there's two numbers. The top number is for 90s, so 90-degree bends. So if I took this 40 and I went to 5/30 seconds, I get 0.273. So that 0.273 right there is for 90. And to prove this, you can take this number below, 0.003034, multiply it by 90, and you should get that 0.273. Just to double check, I'm going to do the math for you. Boom, 0.273. So when will I use this bottom number? I'll use the bottom number for degrees other than 90. Cool? Alright, so we learned a little bit of something here. Let me get rid of all those little white marks. Oh, and all my work. Alright. The K-factor chart. You heard me talk about the K-factor in the end of the last video. So this is for your setback. And my that's funny. It's like perfectly centered on that one. And this one. And then it like goes way off. Weird. Okay, well, it's not going all the way to the right. But, so for setback, you're going to get your K factor times metal thickness plus bend radius. And everyone's like, well, why did we just use, for 90, metal thickness plus bend radius? If you look on the chart, for 90 degrees, it's 1. So 1 times metal thickness plus bend radius is metal thickness plus bend radius. So that's why we just use this. Essentially, we're using K-factor without actually using it. So you'll just find the number of degrees that you bent through. Say it was 45. You would use the number on the chart times the metal thickness plus bend radius, and you'll find setback for other than 90. In case you were wondering what K is, some people wonder, it's tan half degrees that you bent through, also known as theta. So you're using trigonometry without using trigonometry because the FAA gave us charts. Yay! So 90-degree L-shaped sample. Remember, you're going to need metal thickness and bend radius. They should be given to us. They tell us metal thickness is 0.051 and our bend radius is 5/30 seconds. If you do 5 divided by 32, we'll get the decimal point 156. It makes mathing easier to get out of the fractions. Next, we need to find setback and bend allowance. Remember, setback for 90 degrees is metal thickness plus bend radius. So I have 0.051 plus 0.156, and I get I think 206. Ah, 0.207. I forgot about that one. So this is my setback. Bend allowance, you go to that chart. You could also use the empirical formula, which is a bunch of fun numbers multiplied together, or you can just go to the chart. So we've got 51 thousandths. So we're going in here. Our bend radius was 5/32, so we're going here. And it meets up at 0.280. So our bend allowance is 0.280. Boom. So now that we figured that out, we can figure out our flats, flat 1, flat 2. We can figure out our overall length and something called sight line. And I'll explain sight line in a minute. So we got flat 1, I'm going to say that's the 3-inch one. And we have flat 2, I'm going to say that's my 6-inch. We're going to put our desired dimensions minus setback. So 3 minus 0.207 and 6 minus 0.207 gets us the flats. So we'll have 2.793 and 5.793. Awesome. Now, if you'll remember from the last video, we don't do 90-degree bends in metal. They're nice and curvy. So my flat 1 is 2.793. My flat 2, let me extend that a little bit, is 5.793. And right in here is my bend allowance. So when I'm figuring out overall length, I'm going to take flat 1 plus bend allowance plus flat 2 and get my answer. So I have 2.793 plus 0.28 plus 5.793, and I will get my overall length. And I get 8.866. Which, looking at this, I should have 9 inches, right? But because of that shortcut, I'm just shy of 9 inches. Because of the setbacks and my bend allowance, the nice curves. So there you go. You should always be shorter than desired flat 1 and desired flat 2 put together. Always, always, always. Now, what is sight line? Well, when you go to put metal in a brake, and well, I'm going to draw another little picture over here. So I've got a brake, and it kind of looks like that. And then I got a piece of metal coming out. My bend tangent lines will end up underneath and out here. So I won't be able to see where my bend starts. So what I actually need to do is come out one radius so I can eyeball, straight up and down eyeball, where that is. So I'm going to do bend tangent plus a bend radius, or flat plus a bend radius. So I can see on the end of the nose, at the end of the radius, where to line up so I know my bend tangent's in the right spot to get the correct bend. So whatever side you're putting in the brake, so let's say I put flat 2 in the brake, and flat 1 is sticking out over here. Whatever side's in the brake is what I'm using to add the bend radius to get sightline. So in this case, it'd be 5.793 plus 0.156 which equals 5.949. Now let's talk more about these terms that I'm talking about here. We did a little bit in lecture, but just in case, let's talk about some stuff. So we have my beautiful radius again, close up, my beautiful piece of metal that's sticking in the brake. What is this bend tangent line that Holly speaks of that's going to be here and over here? From the edge of the metal to where my bend starts is my flat. Where I mark the end of my flat is called a bend tangent line. In between the bend tangents is my bend allowance. So from bend tangent to bend tangent is bend allowance. And my other flat is way over here. So that's where the next flat begins, is at the next bend tangent line. So everything in the bend allowance will be involved in a bend. So radius. Yay! So then when I'm looking at the brake, I've got this big metal machine, and I've got these rounded noses sticking out. That rounded nose keeps me from seeing that bend tangent line. So with my piece of metal sticking out, all I would see is the other bend tangent line. Well, that's not very helpful. But if I sneak in there, let's see if I can change the color. Let's make it purple or pink, whatever it is. If I sneak in there with a sight line, I can line it up with that nose. Purple didn't work very well. Green. There you go, you can see the green better. But I can see where to line up the nose when I'm looking straight down at that radius. And that's why we have that there. Another thing that you've heard me talk about, let me get rid of some of this, is that shortcut. That's a really bad curve. So flat, curve, flat. Alright, better, not the best. Flat, flat. So in this shortcut, if I was to extend this flat out and the other flat out, at some point they would cross. Where they cross is called a mold point. And those are mold lines coming out. Those lines are those perfect dimensions. Those are the 3 and 6 and what you see on drawings. You'll see mold points, mold lines making it up. You won't see that curve. But we know in real life everything does not do an exact 90. Think of when you're turning your car, for example. When you turn right to go into the school or you turn left to go into the school. You don't all of a sudden make an abrupt left-hand turn. It's a curve. So that's what your metal is doing a curve. And then there's this part of the metal going down the center called the neutral axis. If you go through like metallurgy, you'll realize the neutral axis for aluminum is actually like 0.455 or something, and not exactly 0.5. So it's not exactly halfway through for aluminum. But for all intents and purposes, it's about halfway. The neutral axis is the part of the material that is not bending. What happens on the inside here is it kind of shrinks. And on the outside, I'm going to kind of stretch. So let me change colors real quick. So out here, I'm stretching. So in order to not crack, I have to make sure I stay within a certain minimum bend radius. And you can look that chart up in the AC 4313. They have minimum charts, and they'll say something like half thickness to 1.5 thickness. So you take your metal thickness times half for a minimum, and or like if it was 1.5, you do 1.5 times the metal thickness. So, alright, so we learned some more stuffs there. What about my U-shape example? Let's do metal thickness, bend radius, setback, and bend allowance real quick. So I got 0.040. I got the 5/32 again, so I'm just going to put the decimal. I'm so used to it now. Setback, remember, add metal thickness plus bend radius. So I get 0.196. For bend allowance, always go back to the bend allowance chart. So we got 40 and 5. So I'm taking my 40 out, taking my 5 down. Oh, it's that 0.273 from earlier. So 0.273 from the chart. Now that I have all that fun stuff, I can figure out my flats. So I'll have flat 1, flat 2, flat 3. So I'm going to have 3 inches minus 1 setback. Flat 2 is going to be 6 inches minus 2 setbacks because it's involved in 2 bends. And then flat 3 would be 3 minus 0.196. Again, overall length is flat 1 plus a bend allowance plus flat 2 plus a bend allowance plus flat 3. Ooh. So I'll let you figure out the numbers if you wanted to try it. If you were doing sight lines for these, I have 2 bends, so I'll have 2 sight lines. And what typically happens is you'll do, here's 1 flat plus a bend allowance, flat 2, and its bend allowance. So I'm just drawing it out like you'd see on, say, your toolbox. Oh, yes, I went there. Alright, so there's my flats. In between them are bend allowances. When you're figuring out your sight line, the first one typically goes all the way out, so I'll do flat 3 plus bend allowance plus flat 2 plus bend radius. So what that's going to do is take me flat 3 plus that bend allowance plus flat 2, and then I got my sight line. So my sight line will be somewhere in here. What that's allowing me to do is stick flats 3 and 2 into the brake. I bend up my little flat 1. I'll pull on that bend to find the other flat. So from here, I'm going to go up to there. And in order to do that, once I pull it out flat 2 and flat 1, I'm left with flat 3 plus a bend radius to get to that sight line. Then I'd bend that up and I would end up with this U-shaped box. I would have bent this one first and then this one second. Now for other than 90. Dun 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 dun! The dreaded numbers. Well, we still have metal thickness and we still have bend radius still given to us. I probably should have changed the bend radius to make it more fun here and there, but okay. Now to figure out my setback. If you remember earlier, we need the K factor. So it's going to be K times metal thickness plus bend radius. I need to find that K. In order to do that, I need to know how many degrees I actually bent this metal. So from flat, how far did I bend this? Remember, flat is 180 degrees, so I only bent it 30 degrees. So when I go to my K factor chart, I'm looking for 30 degrees. Let me pull up my red real quick. And I've got 30, giving me this beautiful number. 0.26795. 0.26795. So that's my K factor. Times metal thickness plus bend radius. So 0.26795 times 0.051 plus 0.156, and I get a setback of 0.055-ish. And for my bend allowance, remember we go to our bend allowance chart, we've got 51 thousandths metal, 52 brake, so 51 thousandths, 5/32 brake, and I get 0.003116. So I'm going to use that number, the very bottom number there, and multiply it by degrees bent through. So 0.003116 times the 30 degrees that I bent it through. This beautiful number comes from a really big formula called the empirical formula. I like that the FAA gives it to me, but you could actually go ahead and use pi and figure it all out. 3, 5, blah. So now I have my bend allowance. Woot woot. What am I going to do with all this information? Oh yeah, I've got flat 1 and flat 2 here. I've got my 7 inches and my 4 inches of desired dimension, minus my setback. Oh, that's a 5, it looks kind of like a 3. So 7 minus 0.055, and I get 6.945, and I will get 3.945, and for my overall length, I would get flat 1, 6.945, plus bend allowance 0.0935, because you're not bending it very much, plus flat to 3.545. Nope, it is 3.5. Double checking all my stuffs here. Yep. And I'll get 10.9835 inches, which my desired looks to be 11 inches with a very tiny bend. I only took a very short shortcut. So ba-doom doom. And there we go. So that is degrees other than 90, your U shape, and just regular L shapes. If you need anything else, feel free to let me know.